Today we are going to do this integration from Japanese University Entrance Exam 1979. It was said that no one could solve it, but right now many techniques have been discovered and this question is no longer that difficult. However, it's still quite challenging to many people. You may try it before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
The technique that we're going to use is very simple. Just use a substitution. After we solve this question, we are going to generalize it. Now, we will let this integral as j. I let u to become a negative x. So j itself will be, if it's negative x, it will be from 1 to a negative 1. X squared will be u squared. And this will be 1 plus e negative u. Dx will be equal to negative du. With this negative, then it is still from negative 1 to 1, and this is du. And this is u squared, 1 plus e to the power of negative u. Now, after we have done that, whether you write as u or x, it doesn't matter. So I can say that actually j can be written as negative 1 to 1 x squared 1 plus e negative x dx. So we can write it as negative 1 to 1 x squared over 1 plus ex dx, or integrate from negative 1 to 1 x squared over 1 plus e negative x dx. And therefore 2j, we can take the sum. It will be a negative 1 to 1 x squared 1 plus ex plus x squared and therefore 2j will equal to this value. Now this will be equal to, integrate from negative 1 to 1, this is x squared 1 plus ex, and for this is 1 plus ex times ex, then x squared. After we factorize the x out, they have the same denominator, and denominator will be 1 plus ex. So this will be equal to, integrate from negative 1 to 1 x squared dx, and this is equal to 1 over 3 x power 3 from negative 1 to 1, and this is equal to 2 over 3. Now 2j equals to 2 over 3, and therefore j equals to 1 over 3. So 1 over 3 is our answer for this question. As promised, I'm going to generalize this question. If you enjoyed this video, please like, comment and subscribe. Now we can have a similar question, and we are going to prove negative a to a fx over 1 plus ex dx is equal to integrate 0 to a fx dx if f is an even number. Now, f is an even number, it means that f negative x equals to fx. Or let v to be negative x. Now with this, k will equal to, initially from negative a to a, because v equals to negative x, it will be a to negative a. Fx will be equal to f of negative v, and 1 plus e negative v. Dx is negative dv. So this will be equal to negative a to a. F is even, so f negative v will equal to fv, and this is 1 plus e negative v dv. Similarly, v is just a dummy variable. We can write as x again, so it's negative a to a f of x 1 plus e negative x dx. Now we can sum up these 2k. So 2k will equal to, from negative a to a, fx over 1 plus ex plus fx over 1 plus e negative x dx. Okay, negative a to a. So this will be fx 1 plus ex plus 1 plus ex, this is ex, and fx. So again, this will be from negative a to a, fx, then 1 plus ex over 1 plus ex will give you 1. Now, since f is an even function, so integration from negative a to a fx dx is actually equal to double of 0 to a fx dx. So with this, then we can see that k will be actually equals to integrate from 0 to a fx dx. So for the previous question, fx equals to x squared is an even function. A equals to 1. J equals to integration from 0 to 1 x squared dx. And therefore the answer equals to 1 over 3 for the previous question. So with this, we have proved the general case. That's all for today's question. I'll see you again next time. Bye bye.